Welcome to the 7th video of our series. Today we take a closer look at the piston, the heart of our compressed air engine. We will show you how you can insert the through hole into the rotationally symmetric piston in 3 different ways. In doing so, you will learn 2 new functions: creating a plane tangent to the outer surface and cutting the piston in the sketch view. So, let's get started. First, we create the piston without the through hole. To do this, we begin with a sketch on the XZ plane. To start, we draw the 15 mm long vertical rotation axis from the origin upwards, using the line command and the centerline option. Next, we transfer the piston profile according to the technical drawing, deliberately not considering the hole yet. To fully define the sketch, we use dimensions and constraints. Try to dimension the sketch yourself without directly following the video. If you encounter difficulties, you can always compare your sketch with the video. And remember, there are always different ways to define a sketch, so if you approached it differently, it doesn't necessarily mean you did it wrong. It is important that the sketch is fully defined in the end, so that you have complete control over the component. As an additional aid, you could also load the component drawing into the program, allowing you to easily trace the contour, as with the crank pin. Once the sketch is fully defined, we use the rotate function to rotate the profile around the previously created centerline. Finally, we confirm the process and thus create the basic shape of the piston. In the next step, we create the through hole and demonstrate the first of 3 variants. To do this, we first create a tangent plane on which the hole will later be positioned. For this, we go to Construct in the toolbar and select Tangent Plane. Then we click on the cylinder surface of the piston to create a plane that is tangent to the outer surface. An adjustment of the angle is possible, but in this case not necessary. On this newly created plane, we will now create a sketch. We draw a circle with a diameter of 4 mm in it. To align the circle exactly in the center, we place its midpoint coincident on the z-axis. Additionally, we measured the distance to the bottom edge of the piston with 15 divided by 2 mm to ensure the correct position. Then we use the extrusion command and pull the circular surface into the piston. As boundary type, we choose all, and the operation is automatically set to cut. After confirming the command, our first version of the through hole is completed. To implement the next version, we first suppress the previously created extrusion. To do this, we right-click on it in the construction history and select Suppress Element. Although the extrusion remains in the construction history, it no longer affects the model. For this variant, we create a new sketch on the XZ origin plane. By activating the Slice option in the sketch palette, we hide all component areas in front of the sketch plane. This gives the impression that we are looking inside the piston without the outer walls limiting our view. the section surface is coloured and hatched, giving us a clear view of our sketch plane. Now, as before, we place a circle with a diameter of 4 mm in the centre of the piston. After completing the sketch, the previously hidden area of the piston becomes visible again, and we see the component in its complete form. Now we use the extrusion command again and pull the circular area into the component. We change the direction to symmetric and set the extent type to all to achieve a uniform through hole. At this point, the component would be completed again. To implement the third variant, we also suppress this extrusion in the design history. We select the command hole and click on the cylindrical surface of the piston. Since the hole is perpendicular to the cylindrical surface, it is sufficient to set the distance to the top surface of the piston. For this, we simply click on it and enter 15 divided by 2 mm. Additionally, we set the limit type to all and adjust the hole diameter to 4 mm. To conclude, we confirm the operation and the third variant of the through hole is successfully created. Before we continue, we first remove the suppressed elements from the construction history. This ensures that our work environment remains clear. You should also remove the unused sketches and the tangent plane. In the video, they are not removed so that they can still be seen in the summary. Finally, we assign the material bronze to the component. For this, we select Change Material and choose bronze from the material list. Once the material is assigned, we save the component and finish the editing. With that, you have successfully created the piston and learned about 3 different methods to create a through hole on a cylindrical surface. First, we introduced the hole using a tangent plane. Then it was created with a sketch on the origin plane and an activated section view. Finally, we created it directly using the hole command. These techniques expand your repertoire, allowing you to flexibly choose the appropriate approach depending on the situation. In the next video, we will again use the third variant to solve another exciting task. Stay tuned. You are on the best path to continuously expanding your skills.